Hello, and today we're going to be looking at adding and subtracting polynomials. And that's what we're going to learn today. We're going to learn to add and subtract polynomials. This corresponds to pages 576 to 579 in your textbook. If you don't like my explanation, you want to read it. You can also remember, you can always do a search on TeacherTube or go to Google or go to Math Forum if you don't understand this explanation. First thing, let's define a polynomial. A polynomial is an algebraic expression in which the variable exponents are positive. Or at least not negative. Because if we take a look at an example here of a couple polynomials, a number is a polynomial. Like the number 4 is a polynomial. It doesn't have a variable because we'd say the variable is to the 0 power. We know anything to the 0 power is 1. So 4x to the 0 power would be 4, which is a polynomial. Now if I throw in some exponents, I just have to make sure the exponents of the variables are positive. The number in front that goes, or the number you're multiplying the variable by, doesn't matter. And so I could have a fraction like 3/4 x to the 3rd minus 2x squared plus 5. All of those are polynomials. So what's an example of something that isn't a polynomial? Well, something that's not a polynomial would be something that doesn't have a positive exponent for the variable. So there's no dividing, really, is what we're saying with polynomial expressions. We have another name for that. Those are rational expressions. But like 4 over x is not a polynomial because remember, that would be the same thing as 4 times x to the negative 1. No negative exponents. So you can't have anything with a negative exponent. Something else that wasn't a polynomial would be like a fraction. Where you have the numerator is a polynomial. The denominator is a polynomial. But the whole expression is not a polynomial because with x plus 1 in the denominator, that whole thing would be to the negative. You can't divide. That's the important thing. Standard form of a polynomial. In the examples I gave you of things that were polynomials, all those are written in standard form. We did standard form when we did quadratics. Quadratics don't change too much, so you're not going to see a huge difference in here. Standard form, but let's write it down. That is, we list the polynomial with the largest exponent first. To the smallest exponent last. And something that doesn't have a variable would go lastly. So if I take a look at the examples we have in the first case, 4, well, we only have one term, so that's automatically in standard form. But if I look at the next one, the exponent is 2, the exponent is 1, I don't have an exponent, so it goes 2, 1, 0. The next one, 3, 2, 0. I can skip as long as I have the biggest exponent first. So what I'm really saying is, let's take a look at that something isn't in standard form. And something that isn't in standard form would be like, let's say I had 2x minus 3x to the 3rd plus 2. That's not in standard form because the first exponent is 1, the second exponent is 3. I don't have the biggest exponent coming first. Now the degree of a polynomial is the exponent. That's all it is. Now, there are some more complicated ones. We're going to keep this kind of simple. So if I have like the term 4, the degree is 0. The term 3x to the second, the degree is 2. And the term, 3/4 x to the fourth, the degree is 4. Pretty basic, isn't it? Well, that's for single term polynomials. But if I put them together, connected by a plus sign or a minus sign, it's the degree of the largest term. So let's go back to my polynomials in the beginning. X squared plus 2x minus 2. The first one has an exponent of 2, so its degree is 2. The second term has a degree of 1. The last term has a degree of 0. I don't add them, I don't subtract them. I just say the biggest one, so that degree is 2. In my third example here, this degree is 3. And that's all you have to do when we're talking about degrees. Now, compare that with the coefficient. The degree is the exponent. The coefficient is the number that is multiplied to the variable. Now, if we take a look at our terms of our polynomials back to the beginning, the coefficient is 4 because it's 4 times x to the 0, which is 4. So any number is a coefficient. In the second example, the first x squared has a coefficient of 1 because it's 1 times x squared. The second term has a coefficient of 2. The last term has a coefficient of negative 2. In the third example, the coefficient of x to the third is 3/4. The coefficient of x squared is negative 2 because the sign goes with the number. And the coefficient of the last term is 5. Now, leading coefficient, that's pretty basic. It's the coefficient of the largest term. A lot of vocabulary here to start with. So it's a coefficient of the largest term. So if I, once again, if I look at a polynomial, the leading coefficient of x squared plus 2x minus 2 is 1 because that has the leading term is 1. The leading term of this the third example would be 3/4. If we take a look at in an example that's not written in standard form, the leading coefficient is negative 3. It doesn't have to come first. It goes with the biggest degree. So that coefficient would be negative. The leading coefficient would be negative 3. Now, my first example, identify the coefficients of 4 minus x plus 2x to the third. So my first coefficient is 4. My second coefficient is negative 1. My third coefficient is positive 2. Now, when we look at polynomials, we know we can add or subtract different terms. But we have some basic names for some ones that we see a lot. The first one is a monomial. A monomial is a number, kind of like a polynomial. Actually, it is a polynomial. A number, a letter, variable, or a combination. However, there's no adding or subtracting. So for an example, some monomials could be 4, 3x squared, negative 5x to the third, y squared, z. That all three of these are different monomials. Each one has one single term. A constant term, we kind of alluded to this, but a constant term is just a number only. So something could be a monomial and be a constant, like 4, or negative 6, or 12. Anything that's just a number. That we call that a constant. Now a binomial is two monomials. Separated by a plus or a minus sign. And that's all it is. So once again, let's do an example. X plus y is a binomial. Two terms. X minus 2 is a binomial. They can have exponents. X squared minus 4. Z to the third plus 1. Those are all binomials. And once again, these terms aren't so important. Like, I'm not going to ask you, what is a binomial? Compare and contrast a binomial with a monomial, although you should know the difference. Is just when we're talking about it, when they say write a binomial, you should be able to write, that should appear to your mind, hey, that's two terms. And then, well, trinomial, kind of the same thing. Tri means what? So it's three terms, separated by plus signs or minus signs. So x squared minus 2x plus 4. Now anything over 3, we usually just refer to the general name polynomials. Notice, monomials, binomials, trinomials, they're all polynomials. But anything with more than 4 or 4 more, we just we don't really usually call them by special names. But monomials, binomials, and trinomials occur so often in algebra, we have special names for them. Now, classifying polynomials by their degree. Anything to the 0 power, that means no variable, we're going to call a constant, because it would just be a number. Anything that has an exponent of just 1, we'll call that linear. From last chapter, anything with 2 we should recognize, we're going to call that quadratic. Anything with 3, we're going to call cubic. So something with the 3rd power, that would be a cubic. Anything to the 4th power, we'll call quartic. Anything to the 5th power, we'll call quintic. We have names for those on and on, but usually 1 through 4 is all you should know 1 through 3 for sure. 4 is kind of nice as we move on into some higher functions. Now, if I take a look here at this first example, I want to give the degree of the polynomial, I want to classify the degree, and I want to state the number of terms of each polynomial and classify it. So if I take a look at the first example here, -5. Notice no exponent, so the degree is, or no variable, so the degree is 0. Classified by that degree, that's a constant. I have one term in my polynomial, so I'll classify that as a monomial. Next, 1/4 x. Now it is to the, I do have a variable, so it's to the 1st power, x to the 1st power. So anything to the 1st power is linear. Think back to how I would graph that. If I would graph that, that would make a nice line. That's what we call it, linear. Classified by the number of terms. I'm just multiplying, I'm not adding or subtracting. So this is also a monomial. Notice, monomials can have any type of degree, but only one term. Now if I take a look at the next one, -9x plus 2, notice degree once again is 1, because the exponent is 1. But classifying it by its degree, once again, is linear. The difference this time is, notice I have 2 separate terms, and that would be a binomial. By the way, it's not a binomial just because it has 2 terms. If you can simplify it, if I had 9x plus 2 minus 5, I could combine 2 minus 5. It would still be a binomial. Now if I look at the next one, has a degree of 2. From what we said, that's quadratic. It also has 2 terms, so we'll consider this a binomial again. Okay, next example. The biggest exponent is 3. Doesn't matter what the other exponents are, but it's a degree of 3, so that's a cubic. Has 3 terms here, so we'll call that a trinomial. Finally, the next term, the biggest exponent is 4. So it has a 4th power, and we said that was quintic. And then has 1, 2, 3, 4, 5 terms. So remember, anything with 4 or more, I'm just going to generally call that a polynomial. And that's all I do with that first example. Okay, number 3 I want you to do by yourself. Now, adding and subtracting polynomials. Here's the important thing, and this is where it gets confusing, so pay attention. When we add or subtract polynomials, we add or subtract the coefficients of the like terms. We don't do anything with the degrees. Leave the degree alone. And now in chapter 8, we were multiplying, and we added the exponents. We were multiplying. We're not multiplying here. We're adding. So leave the degree alone. Want to really stress that. Leave that exponent alone when we're adding and subtracting. So first example, I want you to add these. Now, they're in parentheses just to keep things organized. So what I want to do here, and notice the directions say, find the sum and write it in standard form. So I want the biggest exponent first. So I'm going to try to combine that. So I'm going to start here with the biggest exponent. So the biggest exponent, as I look at across all 3 of them, is to the 3rd power. So negative 8x to the 3rd power. I look for all the other ones that have to the 3rd power. So negative 8x to the 3rd power plus a negative 3x to the 3rd power would be negative 11x to the 3rd power. Now I'll turn around and I will look for the things to the 2nd power. So negative 9x to the 2nd plus 8x to the 2nd plus 4x to the 2nd. Now I just add the numbers. Negative 9 plus 8 is negative 1. Negative 1 plus 4 is positive 3. Leave the exponent alone. So plus 3x squared. And then let's turn around and let's do the things to the 1st power. So positive x minus 2x. 1 minus 2 is a negative 1. So I'll get negative x. And then finally, let's add the numbers we have left. 2 plus 4 minus 1. 2 plus 4 is 6 minus 1 is 5. If you can't do the addition in your head, use a calculator. Get the problem right. We're in algebra now. Okay, question 5. Pretty much the same thing. Let's start here with 6x squared, because that's my biggest exponent in this case. So 6x squared plus x squared, that's 6 plus 1, that's 7. 7x squared. Negative x plus negative 2x is plus negative 3x. And then 3 minus 7 is minus 4. Now, I don't care if you write it as minus 4 or plus a negative 4. That really doesn't matter. You simplify it whatever is simpler for you. Now, subtracting is a little bit trickier because we're going to subtract the corresponding terms. But notice here, I'm subtracting the whole parentheses. So I'm kind of like I'm doing a distributive property on this problem. So I'm going to take, and I'm going to say negative 6x to the 3rd plus 5x minus 3. I'm going to change the signs of everything inside the parentheses. So that would become a plus between them. Then negative 2x to the 3rd minus 4x squared plus 3x minus 1. So I'll write that out so you can see a little bit better. So negative 2x to the 3rd minus 4x squared plus 3x minus 1, or plus a negative 1. Now we're going to do it just like I did before. Add up the corresponding like terms. So negative 6x to the 3rd minus 2x to the 3rd is negative 8x to the 3rd. 5x, well, I don't have a squared, so let's go to this. The second term does have a square, so minus 4x squared. Then plus 5x plus 3x be plus 8x. Negative 3 minus 1 is negative 4. Now, one thing to talk about is, we're doing these horizontally, but I can do them vertically too. That is, if I take a look at the second one, that'd be minus 3x plus 2x squared. And so what I'm going to do is I'm going to add them this time. So I'm going to say 4x squared. I'm going to leave a space for the x, minus 1. And then minus 3x goes in the second line, plus 2x squared goes underneath the squares. And then we get 4 plus 2 is 6x squared minus 3x minus 1. So it really doesn't matter how you do the problem. Horizontally, vertically, that part doesn't matter. It's just getting the correct answer. So if I take a look at the last one here, let's do this example, my squared. So I'm going to say change the subtraction to addition, change the signs of everything inside the parentheses. So this becomes 12x minus 8x squared plus 6 plus negative 8x squared. Nope, that's not negative anymore. That's positive. I switched that. Okay, so plus 8x squared plus 3x minus 4. Now, add your like terms. I'll start with the biggest exponent. Notice negative 8x squared plus positive 8x squared, they cancel each other out. I don't have to worry about the squared terms here. Then I'll do my x's. 12x plus 3x is 15x. 6 minus 4 is plus 2. I'm done with that problem. 15x plus 2. Then I want you to try to do number 9. Now let's take a look at number 10. We got a couple different things going on in number 10. It says you're enlarging an 8-inch by 10-inch photo by a scale factor of 2x and mounting it on a mat. We talked about the mat when we did it before. You want the mat to be 1.5 times as wide as the enlarged photo and 3 inches less than 1.5 times as high as the enlarged photo. So question 10 says draw a diagram. So here's I got this mat. It's supposed to be a rectangle. I know it doesn't look like it, but we'll pretend it is. And then inside the mat I've got this picture that's been enlarged. Well, it was 8 by 10, so I'm going to enlarge it by a factor of 2. So I'm going to multiply it. So 8 by 2 would be 16x by 10x, because 10 times 2x is, well, 10 times 2, I didn't multiply it. 10 times 2 is 20x. Okay, now I want to make it 1.5 times as wide. So the mat is 1.5 times as wide. Well, 16x times 1.5, that's 24x. And then I want the height to be 3 inches less. Well, that means I want to subtract 3 from 1.5 times the height. So 1.5 times 20 is 30x. There we go. So the mat is our dimensions of 24x. The height is 30x minus 3. We're using some binomials here. And so that's what we do in number 10. Draw the diagram, label the dimensions, which we've already done. Now write a model for the area of the mat around the photograph. So area, remember to find area, I'm going to make this a little bit smaller so we can see it, is area. I want to find what I'm talking about here. I want to find the area of the mat that's not in the picture. Well, remember from middle school, to find the area of this part, I'm going to find the area of the whole mat and subtract the area of the picture. So the area of the whole mat will be 24x times 30x minus 3. And then I'm going to subtract the area of the picture, which is 16x times 20x. Now we can simplify this. We can apply our distributive property from what we learned earlier this year. Along we can apply we can apply what we learned about multiplying with variables and exponents. So 24 times 30 that's 720. So 720 x squared, because x times x is x squared. Notice when I'm multiplying, I do add the exponents. When I add and subtraction, I leave the exponents alone. Minus 24 times 3 is 72x. Minus, if I take 16 times 20, I get 320x squared. And then, well, I notice that negative 70, no, I notice that, highlighted here, 720x minus 320x squared, well, those can be combined, and since I only had one term here at this time monomial, I don't have to go, I can say plus a negative if you want, but then I'll get 400x squared minus 72x. So this is a model of a problem where x could be any number, and that's all we're doing on this problem. And then number 12 I want you to do by yourself. And let's take a look at 13. Okay, question 13. It says from 1890 through 1990 the number of men and women in the United States can be modeled by the following equations, where t is the number of years since 1890. So the number of men, we got this polynomial that says 0.0016t squared plus 0.315t plus 19.467. The number of women, we have this equation 0.007t squared minus 0.228t plus 5.908. Find a model for the total S. So the total, how do you find total? You add. So that's what I'm going to do. I'm going to add the men. So I'm going to say 0.0016 t squared plus 0.315t plus 19.467. And now this one will make sense to add them vertically because we have such ugly numbers. So plus 0.007 t squared minus 0.228 t plus 5.908. So let's add up those. So if I take probably just do this one. So 0.0086 t squared, keep the exponents the same. And then plus, if I take 0.315 minus 0.228, I would get 0.087t. And then add 19.467 plus 5.908, and I get 25.375. There you are. And that's all you have to do. Now the rest of them I want you to do by yourself. That's our guided practice.